Okay, it should be recording now. Okay, 5-1, 5-2, 5-3 is the notes I gave you on Monday, Tuesday, Wednesday this week. We'll quiz. I'll post a homework quiz on Monday the 30th, which is when the e-learning assignments are due. So probably what I'll check for your e-learning assignments. I haven't quite decided. Either I'll have you show me your notes, and that will be the e-learning assignment for those 3 days, or I'll just take the homework quiz as the e-learning assignment for those 3 days. But either way, I'm not gonna take the homework, so you don't have to show me the homework. Either you'll have to show me the notes for 5-1, 5-2, 5-3, or I'll just take the homework quiz. And then 5-4, 5-5 homework quiz will be due the week after. So we're not doing 5-6 through 5-8 in chapter 5. So you don't have to do those in the note packet. So then 5-4 and 5-5 will be the last 2 lessons in chapter 5. So I will push those out Monday and Wednesday, I think, as the e-learning days, the week after spring break. So I'll push those out Monday and Wednesday, 5-4 and 5-5 notes, and then the homework quiz will be the Monday after. Does that work? Any questions on homework quizzes? Okay. Are there any other questions? Chloe emailed me some earlier this week, and I can go over those. Any other questions? We'll look at 5-1 first. I think, Chloe, your questions were 5-5-1s. Any other questions from 5-1? Can you all hear me fine? Okay, I just want to make sure you guys could hear me. Okay, I'm going to go over questions that Chloe had. They were 69, 81, 91. 81, I sent a revised, sorry about that. I sent a revised list of homework that I forgot to take off, so you should have that. 5-3 I put on Google Classroom yesterday, so that should be good with 5-3. Okay, 69 on 5-1. It's weird because I can't see. For some reason, when I look at my screen, it's backwards. I don't know why. Okay. So let me know if you can't see it. So 5-1, number 69. So the directions for 5-1, there should have been at least one in the notes like this. The directions for 5-1, or for 69 on 5-1, is to write an equation of the tangent line. So we've done it before. Thing to remember is the slope of the tangent line is the derivative. But like I said before we had all of this happen on Friday, Chapter 5 is kind of doing what we've already done before, derivatives and integrals, but it's with different types of functions. So 5-1 focuses on ln, natural log functions, and then 5-2 focuses on more with ln, but integrating ln's, and then 5-3 is focusing on, I believe, exponential and log. Actually, 5-3, I believe, is kind of review from inverse functions. So 5-3 should kind of be review from pre-calc trig, maybe a little bit of algebra 2. Okay. So 5-1, 69. So we're looking for the equation for the tangent line. So here is the original one. Okay, and it goes to the point pi over 4 ln square root of 3/2. And we're looking for, you don't have to worry about parts B and C necessarily. Part A is all I need to worry about. Finding the equation of the tangent line to the graph at the given point. So we've done it before. We just haven't done it We just have not done it using these types of functions, ln. So we're going to find the derivative first. If we find the derivative, remember the slope of the tangent line is the derivative. So the slope of the tangent line is the derivative. So we're going to find the derivative and then plug in my x value, pi over 4. So first thing you're going to have to kind of go back to your ln properties, your log properties from pre-calc, algebra 2. And so this is a natural log. So this is basically log ln, log base, I forget exactly what it is. It's been a while, but it's natural log. This has ln is a natural log, so it has all the log tendencies. I believe it's a log base e. So we can use the property. So if I rewrite it like this, ln of, remember square root is 1 plus sine squared x, so 1/2 power. So if you write it with exponent first, then the properties of log says that I can take the exponents and bring it in front. So I can go ahead and rewrite it like this. So these, before you kind of jump into taking the derivative, you want to use some of the properties of log to rewrite it, write your exponents out front, and then it'll make it easier to take the derivative. And especially on number 80 or 91, when you have to do logarithmic differentiation, that's going to be key. So as you look at this, I'm going to take the derivative of this right here. So the 1/2 just stays there. Anytime you're taking the derivative, multiplying by a constant, it just hangs out in front. And then the derivative of ln, this is basically a chain rule. And my outside function is ln. So we learned in 5.1, the derivative of ln is 1 over x. If it was ln of x, it'd be 1 over x. This is ln of 1 plus sine squared x. So it's going to be 1 over the inside part. And the reason this says 1 plus sine squared x, because we're using the chain rule. Because 1 plus sine squared x is the inside part, so the inside stays the same. Times, don't forget to do this, it's the chain rule, because it's a composite function, times the derivative of the inside. So the derivative of 1 plus sine squared x. Again, this, we've talked about it before. That exponent can go towards the outside. Okay, so if you rewrite it like this, then it's easier to see, okay, the derivative of 1 is 0. When I take the derivative of sine x squared, that's kind of another chain rule here. So it's going to be 2, keep the sine x the same, times the derivative of the inside, which is cosine x. So lots going on with that one. Any questions so far? Okay, so I don't care if you have questions. If you want to interrupt me, you can either chat. I can see if you post it on the chat, or you can just unmute your microphone and tell me. I don't really care either way. So this would be the derivative, and you don't really have to. You can do a little bit of simplification. The 1/2 and the 2 cancel, so that would be written like this. Like I said, when I have my screen pulled up, it's backwards. So if I'm shuffling around, that's why. And then I want to know, to find the slope, we need an actual number. So I evaluate that derivative at pi over 4. So I'm going to take pi over 4 and plug it into the first derivative. So sine of pi over 4 times cosine of pi over 4. So we've done this process before. We're just doing it with ln functions. 1 plus, and I'm going to rewrite it. It's easier to think about it like this. Squaring the whole thing. So unit circle, let me grab mine real quick. Sine of pi over 4 is, they're both square root of 2 over 2. So pi over 4 is square root of 2 over 2. So this will be square root of 2 over 2 times square root of 2 over 2 over 1 plus square root of 2 over 2 squared. So multiply on top, that gives me square root of 2 times square root of 2, 2 over 4. And then 1 plus 2 over 4. So that gives me 1/2 over 1.5, so 3/2. And then the denominators are the same, complex fraction, or you can think about multiplying by the reciprocal. So if I multiply both the top by 2/3, the 2's cancel. That just gives me 1/3. So it tells me the slope, there you go. The slope of the tangent line is 1/3. And the directions asked for the equations. The equation, so y equals mx plus b, like we've done before. Again, the process we've done before, it's just different type of equation. So y equals 1/3 x. 1/3 is the slope of the tangent line. And then to find the y-intercept, to find the b, you plug in pi over 4 for x and ln a square root of 3 over 2. So this would be ln square root of 3 over 2 equals 1/3 times pi over 4. And it's not going to look nice. Your answer, pi over 12 plus b. Subtract pi over 12. And like I said, it's not, remember ln of the square root of 3 over 2 and pi over 12, these are just numbers. But instead of getting decimals, you would just write it like this. So again, it doesn't look nice. Normally we're used to just getting a number for my y-intercept. This is technically a number, even though it looks weird. So then my equation would be y equals 1/3 x plus this whole thing would be your y-intercept. And then part B and C you don't need to worry about. Does that help on that one? Questions on that one? Okay, the other one is 91. And like I said, I will post this as well. So if you need to go back and look, you can. Okay, 91. 91, let's see, 90 through 92, we're using logarithmic differentiation. There's at least one example in the notes. To look at. So if I look at 91, we have use logarithmic differentiation to find dy over dx. dy over dx is just the same as y prime. It's all it means is the derivative of y. There's just multiple ways to watch it or to write it. So 91 is this. And 91 is kind of tricky, so I'll just go ahead and just work through most of it with you. Okay, so there you go. There's 91. That has the x is greater than 3/2. The only reason they have that is because if you look, I cannot take the square root of a negative, so that 3/2 is only there because I can't, that's my domain, because I can't take the square root of a negative here. And in the bottom, there's no value squared that will give me, well, I could have -1, but -1 is not included in this anyway, so that's why they don't have anything about -1, because we're only looking at x values greater than 3/2, and -1 isn't work on this. So that's why they don't have a separate one. So 91, logarithmic differentiation, like I said in the notes, logarithmic differentiation is when it looks complicated. So if you look at this one and you try to take the derivative of this, it will be complicated. You would have the product rule here, you would have the chain rule here and here, and then you like the whole big picture would be quotient rule. So it would be a nightmare to try to take the derivative of. So logarithmic differentiation is the way that we can use properties of logs to help rewrite it, so then it's easier to take the derivative of. So the way you do it is you take the ln of both sides. Okay, so logarithmic differentiation looks complicated, but it's a way to make it easier to take the derivative of. That's the whole point, is you'll be able to use the rules, the properties of logs, rewrite it so it's easier to take the derivative of. So let's go ahead, before I take the derivative of it, I'm going to use the properties of logs to simplify it. So the left side I'm not doing anything with, ln of y. The right side, we're using the properties of logs. So your exponent, I'm going to go ahead and show it using multiple steps. So ln of x squared, if I'm multiplying, I add them. So ln of 3x minus 2, and I'm going to go ahead and write it. It's the square root. I'm going to go ahead and write it to the 1/2 power so I can see the exponent. Minus, since I'm dividing, ln of x plus 1 squared. So we're rewriting using properties of exponents. If I'm adding, if you're multiplying, you can write it as adding. If I'm dividing, you can write it as subtracting. Now you may skip this step and notice your exponents and go ahead and jump down, but I'm just showing you. Now your exponents, I haven't taken the derivative. I'm still just simplifying it. Your exponents on logs can go on front. So I'm taking all my exponents and moving on front. Okay, so I haven't done derivatives. I just used the properties of ln, properties of log to rewrite it. Any questions so far? Okay, so now I'm actually going to take the derivative. So I'm going to take the derivative, and it's kind of like we did with implicit, where we had to put y prime whenever we took the derivative of y. Same thing with this one, except we're putting a dy over dx instead of y prime. So left side, ln of y, derivative of ln is 1 over y. And instead of y prime, I'm just going to put dy over dx. Doesn't really matter, but since the directions say to find dy over dx, I'm using that. And then I'm going to take the derivative of all of these three separately. So the nice thing about using the properties is it rewrites it into 3 separate functions, and those functions are going to be easier separately to take the derivative of. So the derivative of 2 ln of x, where I'm multiplying by a constant, so that's 2. Derivative of ln of x is 1 over x. And then plus 1/2 multiplying by a constant. The derivative of ln of 3x minus 2, this will be a chain rule. So derivative of ln is 1 over, you keep the inside the same, 3x minus 2, times the derivative of the inside. Derivative of 3x minus 2 is just 3. And the last one, minus 2 times the derivative of ln, 1 over x plus 1, times the derivative of the inside, which is just 1. So it doesn't change anything, but we'll just put it there. So it does, using the properties of ln, does make it easier to take the derivative of. Way easier than trying to do it this way. I'm not sure how you do it, but. Okay, let's go ahead. The left side, we just kind of wait till the end because I'm trying to find dy over dx, and so that's what we're going to solve for. So all logarithmic differentiation all kind of have the property where at the end you're going to be multiplying both sides by y to get rid of the 1 over y to get dy over dx, but we need to make sure the right side is simplified. So that would be 2 over x plus 3 over, I'm going to go ahead and not distribute. I'm just going to leave it separate. And then minus 2 over x plus 1. Okay, now it's not a huge deal simplifying here, but the book expects you to, as I'm looking at the back of the book answer, they're expecting you to get common denominators. So my common denominator would be 2x, 3x minus 2, x plus 1. So we're going to try to get each denominator. I'm just taking all these parts separately. So I'm taking my x, I'm taking my 2, my 3x minus 2, my x plus 1, all those separately. Okay, so we're going to look at each fraction. I'm going to go ahead and write my common denominator already. And we're going to look at each fraction and see what part's missing. So this is kind of complicated. It's algebra, but it's kind of messy algebra. So if I look at my first fraction, I'm missing the 2, I'm missing the 3x minus 2, and I'm missing the x plus 1 in the denominator. So I'm going to take 2 times everything except for the x part. This is going to be 2 times the 2. I'm writing it all out. You could do the 2 and 2. Since I already have the x, I don't include the x. I need to include the 3x minus 2, and I need to include the x plus 1. So that's just my first fraction. I only had an x in the denominator, so I had to multiply by the 2, 3x minus 2, and x plus 1. Middle fraction, I already have the 2. I already have a 3x minus 2. So I'm going to take the 3 and multiply by the x. That's what's missing. And I already have the 3x minus 2, so just the x plus 1. And then finally, this last fraction, I already have an x plus 1. So I'm going to have to multiply this negative 2 by 2 by the x and the 3x minus 2. So it will be negative 2 times 2. I mean, you can write them together if you want to. X minus 2. So complicated, but you've done this process before. So we were just going through each denominator, seeing what's missing, and multiplying the top part by that. Any questions on that? Okay, so then simplify the top. You have a good amount of foiling to do. So this would be 4, 2 times 2. If I FOIL these two, that will be 3x squared plus 3x minus 2x minus 2. And then this would be 3x squared plus 3x. And then basically I'm distributing a negative 4x through. So negative 12x plus 8x, 12x squared. All over the, I mean, you don't really have to write you can wait to write the common denominator. We know it's there, but you can just wait to write it at the end if you want to. Distribute the 4, so 12x squared plus 12x minus 8x, which you could have combined those, but whatever, minus 8 plus 3x squared plus 3x minus 12x squared plus 8x all over denominator. Let's do x squared, so that will give me x squareds cancel. I have a 3x squared left. 8x is cancel. 12x and 3x, 15x. And then I have the minus 8 all over 2x, 3x minus 2, x plus 1. And I still have the 1 over y, dy over dx. Okay, lots of simplification on that one. Questions on that so far? Okay, so now I want to get dy over dx alone. I want to solve for that. So I'm going to multiply both sides by y. And this is kind of all logarithmic differentiation kind of have this thing, this last step. So dy over dx, I finally have it solved for what I want. And when you multiply by y, you just take the original y value and you just plug it in. So I usually just plug it in front. So x squared, square root of 3x minus 2 over x plus 1 squared times this mess, or this mess, yeah. Your x squared plus 15x minus 8 over all this stuff. So logarithmic differentiation, just like implicit, doesn't always look nice. There's a little bit of simplification I can do here. This x can cancel. We're all multiplying here, so I'm allowed to do this. So this x can cancel. This becomes just x to the first. We notice x plus 1 squared and x plus 1. That'll become x plus 1 cubed in the denominator. We also notice this 3x minus 2. This is the same as to the 1/2 power. So I can actually take this and think about subtracting it, this and this. This is 3x minus 2 to the first. This is 3x minus 2 to the 1/2. So 1/2 minus 1 is a negative 1/2. So actually that will go, since it's a negative 1/2, that 3x minus 2 will be 1/2 power in the denominator because it was 1/2 minus the 1. So negative 1/2, so that will move it to the bottom. The top will be an x left, so I can distribute the x through. So 3x cubed plus 15x squared minus 8x. And the bottom, I have the 2 out front. The x was canceled. The 3x minus 2 I took care of. And then I have an x plus 1 to the third. So lots of simplification on that one. Does that help on that one? Okay. 5.2. Any questions on 5.2 you'd like me to go through? How far are we on 5.2? Are we getting through 5.2 okay? Homework wise, how far are we on that? Okay. So 5.2, I'm hoping if you're not all the way through it, like I said, I kind of pushed, like normally I think I make 5.2 a 2-day lesson, but I wanted to get through it because you had Thursday, Friday to work on it since you're not getting any new assignment. So I kind of pushed 5.1 through 5.3 through, knowing you had today and tomorrow to kind of work on homework as well. Okay, no questions on 5.2. Any questions on 5.3 by chance? I'm assuming we're not quite done with the homework, but okay. Next week, spring break. So I wasn't necessarily going to do this to have a session over spring break. Would it be helpful to do another one of these tomorrow to go over questions for over 5.2 and 5.3 if they pop up? You let me know, yes or no. I'm flexible if you want to do another one tomorrow. Comments tomorrow, yes, no? 46. Is that on 5.2, Chloe? 5.3? Yeah, let me look real quick. 46. Like I said, I think 5.3, the nice thing about 5.3 is that it should be a decent amount of review, hopefully. I mean, you probably haven't seen it for a while, but it's not. 5.3, 46. Yeah, 5.3 is looking at inverse functions, so you've seen them before. 46. Like this. State the domain. You just need the domain and range part D. Okay. So the domain and range of f and f prime, like I said in the notes, the domain and range are switched. So the domain of the normal function f becomes the range of the inverse. And the range of the original one of f of x becomes the domain of the inverse. So that's probably the easiest way to do it. Look at your original and then just switch them. So if I look at the domain of f of x, the domain is what x values cannot exist. Basically, like we talked about domains, I can't take the square root of a negative, and I can't have 0 in the denominator. So there's no square roots. The only way I'd get 0 in the denominator is if x is 0. So you could write it a couple different ways. Negative infinity to 0, 0 to infinity, or all reals except 0. So then that's also the range of the inverse. And then the same thing, the range of f of x. And to find the range, it's a little trickier, but you're thinking about, okay, what types of numbers am I going to get back? So the range is f of x or y, which is the same thing. So what type of values am I going to get back? So if I think about this, I could get back positive and negative values because I can plug in any number except 0. So I could get, if I plugged in positive 4, if you use actual numbers, if I plug in positive 4, I get back positive. If I plug in negative 4, I get back positive as well. But if I plug in like negative 1, I get a positive or a negative, so I get negative. So you can get positive or negative answers. However, this one's a little tricky. The number I cannot get back is I cannot get back 1 ever, because if you think about it, the only way to get back 1 in a fraction is for the top and bottom to be the same. Well, if x is the same number, there's no way I could get the top and bottom to be the same, because the top is always x plus 2. So whatever your number is, let's say x is 3, there's no way I can get 3 over 3 because the top is always 3 plus 2. So the top will always be different than the bottom. So you can get everything except 1. Hopefully that helps. That was a little confusing. But if you look at it, there's no way to have the same number on top and bottom, so there's no way you get 1 back. So then that would be the domain of f inverse. Does that help on that one? Okay. Tomorrow, yes, no, email. How about you email me? If you're not quite sure, email me. I can either answer your questions individually, or if there's a lot of you who want to meet tomorrow, do this tomorrow, we can kind of figure out a time if you're getting stuck on the homework questions. So any last minute questions before I end it for today? Don't forget, here is kind of the breakthrough. So 5-1, 5-3, I will be uploading the homework quiz. They may be a little trickier questions just because they're going to have access to, and I'll probably pick mostly evens because I know odds would be accessible to CalcChat or whatever. So make sure you're doing it and showing your own work and not the work that's on whatever online. So I will have 5-1, 5-3 homework quiz on 3:30. I'll post it. Probably the easiest way is there's only 8 of you, so I'll post it. You'll look at it, you'll answer it on a separate sheet of paper if you can't copy or print it off, and then just take a picture and email it to me. I'll have the directions on Google Classroom though. And then 5-4 through 5-5 homework quiz will be the Monday after, and then 5-6 through 5-8 we're not doing, so those will be posted. And then after chapter 5, the week after, we'll start the additional lessons for IU. So my plan is to get through all the notes we need to finish, and then after that, we'll see. Hopefully we're back after the second week and we can start taking the tests. If not, we'll figure something else out. Any questions? We good? Okay. Email me if you have questions. Use my Google Voice, but I think we should be good. So have a good day. Email me if you want to do this tomorrow, or email me questions or whatever. So talk to you guys later. Have a good Thursday.